This video is about electromagnetic waves. After working through this assignment, you should be able to relate the frequency and wavelength to the speed of an electromagnetic wave, state the speed of light in a vacuum, relate the magnitudes of the electric and magnetic fields in an electromagnetic wave, and relate the index of refraction of a medium to the speed of light and to the frequency and wavelength of light in the medium. To get the most out of this video, you should have a solid understanding of sinusoidal waves, where k is the wave number, which is equal to 2 pi over the wavelength, and omega, which is 2 pi times the frequency, is the angular frequency of the wave. And you should know that the speed of any wave is equal to its wavelength times its frequency, or its wavelength over its period. An electromagnetic wave is comprised of electric and magnetic fields that oscillate in space and time. The electric field vectors are always perpendicular to the magnetic field vectors. Here, the electric field oscillates in the positive and negative y direction, while the magnetic field oscillates in the positive and negative z direction. The wave propagates or travels perpendicular to the y and z directions along the x-axis. To determine the direction of the electromagnetic wave, you can use a right-hand rule. Point your fingers in the direction of the electric field at a point in space, and orient your hand so that you can curl your fingers in the direction of the magnetic field at that point. Your thumb will indicate the direction that the EM wave propagates. The function that describes the electric field in this electromagnetic wave is Emax sine of kx minus omega t, and the magnetic field is described by Bmax sine of kx minus omega t. The value of k, the wave number, is the same value. This means the wavelength of the electric field oscillations is the same as that of the magnetic field. If the electromagnetic wave is plotted as a function of time, you can measure the angular frequency omega, which is also the same for E and B. This means the electric field and magnetic field oscillate with the same frequency and have the same period. The speed of any wave is equal to its wavelength times its frequency, and for an electromagnetic wave in a vacuum, this speed is equal to 1 over the square root of epsilon naught times mu naught. This value c is called the speed of light. Epsilon naught, the permittivity of free space, is 8.85 times 10 to the minus 12 coulombs squared per Newton meter squared, and mu naught, the permeability of free space, is 4 pi times 10 to the minus 7 Tesla meter per amp. This equates to 2.998 times 10 to the 8 meters per second, the speed of light in a vacuum. The electric field magnitude is proportional to the magnetic field magnitude in an electromagnetic wave, and the proportionality constant is c, the speed of light. This means that if you know the amplitude of the electric field or magnetic field in an electromagnetic wave, then you can find the amplitude of the other field. For example, if an electromagnetic wave traveling in a vacuum has an electric field amplitude of 7 megavolts per meter, what's the amplitude of the magnetic field? Solve for Bmax, which is Emax over c, where c is the speed of light in a vacuum, and you get 23 millitesla. Sometimes, though, you might know information about other properties of EM waves. X-rays are electromagnetic waves with frequencies ranging between 3 times 10 to the 16 Hz and 3 times 10 to the 19 Hz. For X-rays in vacuum, what's the wavelength if the frequency of the X-rays is 9.44 times 10 to the 17 Hz?